Continuing question number 6. David studied the effect of surrounding temperature on the life cycle of organism G. Okay. His findings are shown below. So first things first, always find out what is your change and measured variable. So sometimes, right, based on the aim, you can find out what is the change and measured variable straight away. Because if you recall in my previous video, I told you that the aim is actually to find out how the change variable affects the measured variable. So this is your change variable and this is your measured variable. Okay, so once again, take a look at the trends and then draw your arrows to actually denote. So this, when you read it this way, go down, this is actually increasing, and this on the other hand is decreasing. So once again, the arrows will tell you that they are reading in the same direction, but the trends are different. So from David's finding, how would the temperature affect the length of one complete cycle of organism G? So based on this, I know that as the surrounding temperature, or as the temperature of the surrounding increases, comma, the number of days for one complete cycle decreases, right? So from here and here, we'll be able to tell they are opposing. Okay, question number 7. Amy wanted to find out how the temperature of digestive juices affect the rate of digestion. So based on our prior knowledge of an aim, we know that this is the change variable and this is the measured variable. Okay, she placed 3 identical biscuits into 3 beakers containing liquid Z. Okay, a digestive juice as shown and set up P and Q as shown below. Okay, based on the table above, state the relationship between the temperature of digestive liquid Z and the rate of digestion of the biscuit. So once again, annotate. This is your change variable. This is actually measured variable. Okay, now this is something new that I would like to point your attention to. Sometimes the change variable, or rather sometimes the measured variable is a proxy, of something else that you want to actually find out. Proxy means representation, because certain things that you want to find out cannot be directly measured. For example, rate of photosynthesis. You cannot directly measure the rate of photosynthesis because you cannot see it happening. But there are certain things that will happen during photosynthesis. So for example, during photosynthesis, oxygen is being produced. So when you count the number of bubbles that occurs with each minute, that can be a proxy for rate of photosynthesis. The more bubbles per minute, the faster the rate of photosynthesis. Another example, you cannot really measure the rate of evaporation, but if you measure the volume of water left behind in a beaker, you can use that as a proxy. The lesser the amount of water left behind, the faster the rate of evaporation. So this is actually a proxy. You are not measuring the rate of digestion, but you are you're using the mass of biscuit, okay, as a proxy to rate of digestion. So the lesser the amount of biscuit left, the mass of it, the faster the rate of digestion. Do you understand? So when you look at an experimental question, you need to ask yourself, what exactly is the experiment measuring and what are they using to represent and why? So you need to justify that part. So because when you digest something, obviously at the start you get 80 grams of biscuit. So as you digest, the biscuit no longer remains as biscuit. It gets broken down into a simpler substance. So the original form of biscuit will get lesser over time, technically speaking, right? Or if it's the same time, because of the different conditions present, they will have different amounts remaining. Okay? So once again, we do our arrows. So this way is actually increasing. So the temperature is increasing, and this way you realize that the mass of biscuit is actually decreasing. So when it's decreasing, because it's a proxy, what does it actually mean this time? Alright? It actually means that it's an increasing rate of digestion. So you will need to do a bit of information processing at this point. You cannot just straight away say mass of biscuit. So just like how I explained to you, even the question is asking for relationship between temperature and rate of digestion. You see, they do not ask you for mass of biscuit. You realize that? Because mass of biscuit is a proxy. So how would you say this? So as the temperature of digestive liquid Z increases, rate of digestion increases. Okay? Here. So this, you're going to get quite a number of questions that are similar to this. Especially, I can name a few topics just to help you. Photosynthesis is one of them. Light intensity. As light intensity increases, rate of photosynthesis should theoretically increase. Because, why I say theoretically increase? Because don't forget, photosynthesis is not just based on one factor on light. There are many factors such as availability of carbon dioxide, availability of water, as well as temperature. So you can increase the light intensity all you want, but if there's not enough carbon dioxide, your rate of photosynthesis will not increase. Also, bearing in mind that if, let's just say, all the chloroplasts have already absorbed maximum amount of light intensity, increasing light intensity will not cause a faster rate of photosynthesis, if you get what I mean. Because all the chloroplasts already used up already. They are busy with absorbing, they are working at maximum capacity. So there's no way it can absorb even more light. So in that sense, you should see that, it remains constantly high, that's all. So don't be so assuming that increasing light intensity definitely will lead to an increase in photosynthesis. I just wanted to teach forward so that you can make sense when you see such questions. Okay? Next. Now, what happens when you see two variables? sometimes in questions, they can present to you two different variables, okay, and you have to superimpose, meaning that you have to match the two together to make sense. So let's take a look. What does it mean? So the graph X shows the percentage of oxygen, okay, present in the air at different heights above sea level. This is for graph X. Okay, I'm going to use blue to annotate this. And then after that, graph Y shows the number, okay, of red blood cells present in the blood of a human being. Okay, so basically, as you can see, what is the change variable? The change variable here is actually the different height. Okay, this is something that you're able to change, right? So you get the man to stand at different height. For example, if you want to measure blood oxygen at 100 meters above sea level, you get him to stand at 100. If you want him to go higher, you ask him to climb a few more steps, and then you take the measurements. So this is your measured variable. Okay? And then after that, you realize there is a second change variable. Measured variable, and that is your number of red blood cells. But you realize they are they are separate. Okay, so you can view them as separate experiments, but they are taken at different. They are taken separately, but yet they are together because the same change variable is there, which is height above sea level. Okay, this is the same. Now, then after that, they asked you, based on the graph above, what is the relationship between percentage of oxygen in the air and number of red blood cells found in human beings with increasing height, okay, above sea level? So the first thing you need to do is to identify the CV, which we already did, right? Which is height above sea level. The second thing is to look at the different measured variable, which we also did. Okay, now the next question here is to ask ourselves. This is the main key thing. Does your measured variable 1 affects measured variable 2, or is it the other way around? Cause and effect. Okay, so how do you know this? So this is where you need to ask yourself, okay, your theory comes in, right? Your theory comes in. Now, what is it that is already there that you cannot change? Is it your percentage of oxygen in the air, okay, or is it the number of red blood cells? Ask yourself this question, right? And we should also look at the trend. So with this, you take a look. If it's me, I will write it down. So as the height above sea level changes, the percentage, okay, I'm just going to put here, as the height above sea level increases, percentage of O2 decreases. Okay, and for this other one would be as the height above sea level increases, number of RBC increases. Okay. So now that I have these two trends written out, I can then start to process in my mind. What is it that, okay, causes the other one to change? Obviously, then ask yourself this case. So let's just say I pump more red blood cells. Okay, this is MV2. We're going to call it MV. Okay, sorry. Let me color code it correctly. Because I use blue here, right? Okay, so this is MV2 and this is MV1. So think about it. Ask yourself, what is it that I change, alright, will not change the other? So for example, if I decide to increase my red blood cells, I artificially pump more red blood cells into this human being. And then I put him at a certain height. Does it mean that the percentage in the air of oxygen will change? Ask yourself this question just by putting more. No, right? So then I know that, this thing does not affect the oxygen. So it cannot be a cause and this cannot be an effect. But say, okay, I decided to reduce the amount of oxygen. But then, okay, would it affect the number of red blood cells in my body? And the answer is yes. Because now that there's less percentage of air in the atmosphere, my body is going to work harder to pump the same amount of oxygen to all my cells. To compensate for that, what can I do? Increase the number of red blood cells, right? So you need to use your theory for your understanding. What is the function of red blood cells? So function of red blood cells is to transport oxygen. Around the body to all the cells, right? And why do you need to transport oxygen? It's for respiration to happen. So if I don't transport enough oxygen, respiration cannot take place and this person will eventually die. Right? So to compensate for that, that's why as you go higher up, you will see that there is an increasing trend of production of red blood cells. This is to compensate for the decreasing trend of oxygen. More red blood cells to transport more oxygen because oxygen in the air is actually decreasing. So, to answer this question, you would say that, okay, as the percentage of oxygen in the surrounding decreases, number of red blood cells in a human being, in human beings, increases. Now, you need to be very careful. So this is actually your MV1. And then this is your MV2. Okay, now be very careful. Not say be very careful, sorry. I just wanted to give you general knowledge. This is not talking about one human being. You realize it's human beings. And this is not taken at a specific time. It is taken over a period of time. Because your red blood cells production cannot just shoot up on the same day or within the same hour. It doesn't make sense like that. So what they do, just in case you're wondering, how is it possible? So they take the reading of a person over a period of day or a population of humans over a period of time. Okay? Or okay, at one time, okay, they straight away take, okay, so the population of the people, all right, at 100 meter is X amount. Then they climb up to the second level, 200 meter, okay, all the people, they are different people, not the same person, okay, is this amount. Then they go higher, they take again. Then they realize that, okay, as I go higher, right, when I measure the whole entire population, okay, it will start to increase. I will see increase. Okay, so they may not be the same person. It can be the same person, but to my understanding, they probably took a whole population who lives at that height. Okay, so what some athletes do, in order to up their training regime, right, they actually cycle and they run at very high altitudes for long period of times. So they force their body to produce more red blood cells to be more efficient. Then they come back down and they compete. So in their bodies, there's actually more red blood cells to transport more oxygen to their muscle cells so that more respiration can occur, releasing more energy for them to run even faster. Okay, so that's a trick. Okay, now moving on. Okay, we're going on to this thing called conclusion questions. So in short, conclusion question is asking you what can you tell, all right, from the experiment. Sometimes the conclusion question, the answer for it looks very similar to a relationship question. Yeah, like what is the relationship? Okay, I'm going to teach forward now. So for example, you carry out an experiment whereby you increase the light intensity. And then after that, you count the number of bubbles produced per minute for this plant. And you realize that as you increase light intensity, number of bubbles actually increases. Alright, so what does this tell you? So as light intensity increases, rate of photosynthesis increases. So it looks very similar to a relationship question. But they ask you, what can you conclude? Okay, just telling you, just in case you're wondering, isn't it the same? Yes, sometimes it can be like that. Okay, so let's go on to read. So the first thing they tell you is to identify the CV and the MV. We already know that. And observe how CV affects MV given the data. So isn't that like a bit like a relationship question? Yes, it is. But it may not be always the case, so let's go on. So there are some commonly changed variables and what they represent. So remember I talked about proxy representation. This is exactly what I'm talking about. But obviously not everything can be compartmentalized. So that's why when I taught the earlier part over here, I also have to cross into conclusion questions, what is needed for you. Okay? So this is a proxy. So for example, size of food piece, what the variables actually represent is the exposed surface in contact with your digestive juice. Right? That is what it represents. And then distance between submerged plant and light source, light intensity. Okay? Or amount of light received by submerged plant. Now, I would like you to use this term light intensity because that is the correct quantitative term for amount of light given. Okay, you have to learn this. And when it comes to amount of gases, it is volume of gas, liquid is volume, and not amount. So you need to know this. Wing-like structure, exposed surface area in this with the surrounding. Now, I want everybody to pay attention. I'm going to highlight this in bright yellow. Okay, bright yellow, which means it's extremely important. Whenever you talk about exposed surface area, you need to tell me with what. With what? Please do not leave it your answer as, oh, increasing exposed surface will result in da da da. It does not make sense. Exposed surface area to what? To digestive juice, to surrounding air, okay, to increasing temperature. I don't know what is it. So the main thing about it is you need to be specific. So when will you use this kind of thing? So for example, okay, increasing rate of evaporation, right? Think about it. So let's just say you have a metal pot. You want to talk about how the metal pot actually gains heat. Okay, I'm going to forward teach again. So if you have a pot, two pots of identical size, and then one pot has a heating element that looks like this, and another one that looks like this. And then after that, water is at the top. Okay. So this question is actually about exposed surface area to the metal pot, okay, for your heating element. So if you were to zoom in and see, right, this part over here and this part, obviously between A and B, B has a larger exposed area of the heating element to the pot. So therefore, rate of heat gain by your pot will be faster. So you cannot just say, oh, exposed area of the heating element in A is lesser than B. Exposed area to what? To the pot, right? Or in contact with the pot. Okay, in fact, sorry, if I may correct my statement, it should be area in contact with the pot, because this part is not really exposed, right? So in fact, the part that is exposed to the air is actually more of like this part over here that's exposed. Whereas this part is actually the area in contact. But my whole point about it is really, what is it with? You need to be very, very explicit. Okay? So if I'm talking about evaporation question, I would say that, okay, let's say I got two similar beakers. One, you put a very big container, and then this is water, this is water. This is A and this is B. So I ask you, oh, which beaker, the water in which beaker will evaporate faster? You would say that the water in beaker A will evaporate faster as it has a larger exposed surface area in contact with the air. Okay? So exam, you need to write this up. Now, number of batteries in the circuit means amount of electric current flowing through the circuit. So how does this play? What will you see this in? Electromagnets, brighter bulbs. So I think in a certain way, right, when you do enough practice papers, I'm going to be very upfront with you. Theoretically speaking, you should be able to apply what you have learned even in novel questions. But because we are so exposed to so many questions, right, to the point that one look at it, I roughly would have known what are the common things they will test. If I see a metal rod with coils around it and batteries, it's testing your electromagnet. And how do you increase that? I add more batteries. And then I'll get a stronger electromagnet. If I see bulbs, brighter, less bright. Okay, so these are things that you need to know. And you should be familiar. Okay, some measured variables and what they represent. So, amount of food left means rate of digestion, like what I told you, is a proxy for that. Number of air bubbles, rate of photosynthesis. Time taken for fruit to reach the ground. Amount of air resistance, right? Okay, number of paper clips strength of magnet. So certain things you cannot measure directly. So what do? You use a proxy. So this is very explicitly spelled out for you. In theory, technically, we are not supposed to do this. You are supposed to be able to tell because you are very good in your thinking and you will have thought through and figure this out on your own. But because these are the common things, so obviously, if you want to be exam smart, you will have memorized this. Now, question 9. Terrin wanted to find out how the distance between the torch, okay, and the sensor affects amount of light detected by the light sensor. So distance between torch and light sensor tells you light intensity. What does it mean? This is not only the change variable, but in this case, what it actually represents is your light intensity. Okay? Affects the amount of light detected. This is your measured variable. So in this case, there is no representation. It's really literally just the amount of light detected. It's not representing photosynthesis, it's not representing anything, it's just amount of light detected. Okay? So based on the aim of an experiment, what can Terrin conclude from her experiment? So because in this case, there is no representation, no other representation for your measured variable. It's really literally the amount of light detected, right? But what is being changed here? Your distance. Okay? But what? Okay, so what exactly is being noted here is your amount of light. So it's a very straightforward thing. Once again, I would do my arrows to help me understand. So this is actually increasing and this is actually decreasing. Right? They're both in the same direction. So very straightforward, I would say as distance x increases, okay, light intensity detected by data logger decreases. Okay? Very straightforward. Next, Carl conducted an experiment to find out if magnetic strength of magnet bars increases with size. So in this case, this is my measured variable, this is my change variable. He hung 3 magnets A, B, and C and demagnetized iron bar Z at the different distances away from similar plastic trays filled with equal number of paper clips. The result of his experiment is shown below. Based on the aim of his experiment, what can Carl conclude about the size of the magnets and the number of paper clips attracted? Now, in this case, right, you realize something very interesting. There is more than one change variable. Okay, so we're going to call this change variable 1, and then after that, let me use another color. Okay, different distances away, this is change variable 2. Alright, so now how can we then make sense of this? Right? Based on his experiment, what can Carl conclude about the size of magnets and the number of paper clips? Okay, if you take a look at this, okay, what do you realize? So we need to see a few things. Now, the smallest magnet is actually B. Correct? So if I were you, I know in exam you cannot be annotating everything. So basically, use a code word, whatever, shorthand. But because I'm explaining to you, I'll write it down. This is the smallest, alright? This is the largest. And then after that, followed by this one over here. This is actually, okay, sorry. Let me change this. I'm going to use numbers to represent. I think it's easier. So the smallest is B. The second smallest is Z, followed by A, and then after that, C is the biggest. So the bigger the number, the bigger the magnet. Okay? Now we also take a look at the distance. So if we take a look at the distance of all the magnets, the one that is the shortest distance between the magnet and your paper clips would be Z, followed by A, and then after that you have C, and then B is the greatest distance. So now you need to then put in the two trends together. Actually, this is a little bit like this other question that we have attempted. There are two measured variables, okay? But there are also two change variables. So you need to see if they make sense. Oh, sorry, there is one measured variable, but then there are two change variable. So in this case, we see how many paper clips is being magnetized. Okay, so this is 2. This is actually 3. This is 4. And this is 4. So based on this, are you able to make any conclusion? So you take a look at it. If I have the biggest one over here, does it also mean that I would have the most number? Okay? So yes, it may be the biggest, alright? But yet my distance is not the greatest, I get 4. But yet, if we take a look at the smallest, it also got 4. And moreover, my distance between is the greatest. Right? So when you think about it in this way, alright, the stronger the magnetic strength, the more paper clip it should actually attract at a greater distance. So when you look at what is being changed over here, the size, you're not able to conclude that the bigger the size, the stronger the magnetic strength. Correct? Because of these two extremes. This will tell you already. This is the smallest, this is the biggest, but they both attracted the same number of paper clips. What's even more surprising is that the smallest actually is able to attract equal number at a greater distance. Okay? Whereas the other two also is not very conclusive. So you would have, if size did matter, you would also see a trend, but you don't see any trend here. Nothing at all. Okay? This is actually, alright, smaller than this. So technically, if you tell me the smaller it is, the stronger the magnetic strength should be, right? Then this one over here should technically attract more than this, or rather more, at least more than this amount, given that it's a closer distance. But that did not happen. So because of this, you would say that, what can you conclude? So the size of magnet does not affect, so you copy back, okay, or does not increase, okay, the number of paper clip attracted. Okay, the size of magnet does not affect the number of, okay. Or another way is you copy back the exact same thing, okay? Increasing size of magnet does not affect the magnetic size or magnetic strength of your bar magnet. Okay,